Hi, my AB Calculus students. We are working on a nice crazy question. 2018 number 5. Topic is everything. It's kind of random, but it's very important. This is what your AP exam is going to be like this year, those of you who are part of the coronavirus year. They're just going to throw a bunch of stuff. So here's a question that tests a bit of everything, and that's what the AP exam is starting to head towards, and definitely this year. Okay? So let's go ahead and start the first one, part A. They're like, hey, does this person know what average rate of change is? Now, average rate of change is not the same as the average value of a function. Average rate of change is f. It's the worst f ever, I apologize. Just fast forward that. F of b minus f of a over b minus a. Average rate of change means slope, so average slope is slope through the endpoints. Average rate of change. Average value of a function is 1 over b minus a, integral a to b of whatever function you're dealing with. So this is average value of a function. This is average rate of change. This is average value of a function, average height of a function, average temperature of a function, average anything else. Average rate of change is this, average anything else is this. The AP exam this year, with the coronavirus, this is not a topic. This is the only one you have to worry about, and that's what they're asking for here. So here for part A, they want the average rate of change on the interval 0 to pi. Well, that means it's f of pi minus f of 0 over pi minus 0. Or in other words, let's find these ordered pairs. What does f of 0 equal? And what does f of pi equal? And we're going to go ahead and find them by plugging them in. So let's put a 0 there. So if you put a 0 there, you get e to the 0 cosine of 0. Folks, really quickly, at 0 you have the ordered pair 1 comma 0. Remember, it's cosine of sine, so cosine of 0 is 1. So this is 1 and this is 1, which is 1. So here we have the ordered pair is 0 comma 1. And now let's plug in a pi. E to the pi, cosine of pi. And if you go over here to where pi lives, you have the ordered pair negative 1, 0. And again, this is still cosine. So it's e to the pi times negative 1, which I would call negative e to the pi. So this one gives you the ordered pair, pi comma negative e to the pi. All right, so now we want the average value. We just want the slope through those, and that's what we're going to give them. So this is part A. So I have f of pi. I'm just going to subtract the y's on top. The x is on the bottom. So it's negative e to the pi minus 1 over pi minus 0. Can you simplify this? Not really. I mean, you could say that's just pi, but that's it. That's part A, and we're done. Average rate of change, and there you go. All right. So now let's go look at what they want for part B. So part B, write the slope of the tangent line of f at x equals 3 pi over 2. So folks, f of x is e to the x cosine x. And what you have to know, and they're not telling you to do it because they want to make sure you know it, the slope of the tangent line comes from the derivative. So when they say what's the slope of the tangent line at 3 pi over 2, you are trying to find what is f prime 3 pi over 2. Now if they would say just find f prime 3 pi over 2, then they're not testing two ideas. They're testing two ideas by first telling you to find the slope of the tangent line. So they want to see, do you know that? Does that mean take the derivative and plug it in? So we got to take the derivative, but you cannot take the derivative without doing the product rule. So we have the first piece times the derivative of the second piece. The derivative of cosine is negative sine times chain, but there's no chain, or chain's 1. So that's first piece derivative of the second plus the second times the derivative of the first. The derivative of e to the x is e to the x. from here we just plug it in. Now I'm going to put the negative in front. So I'm going to do negative sine of 3 pi over 2. Sorry, I just like having that in front. E to the, and again, pi is being, x is being replaced with 3 pi over 2. So that's that and that. And over here we have cosine of 3 pi over 2 times e to the 3 pi over 2. So we took the derivative, we're plugging in 3 pi over 2. And just a quick thing, at 3 pi over 2, 3 pi over 2 is down here, of course, we have the ordered pair 0, -1, and that's your cosine and sine. So sine of 3 pi over 2 is -1. So here's an answer I get. There's the negative already in front, so it's negative. Sine of 3 pi over 2 is -1. And there's nothing I can do with this, so I'm going to leave it. Over here, this is 0. Cosine of 3 pi over 2 is 0, and 0 times anything goes away. So if you wanted to simplify it, which you don't have to, negative times a negative is a positive, here you get e to the 3 pi over 2, and that all goes away. And that is your final answer. I'm just double checking to make sure it's right, e to the 3 pi over 2. Great, and that is the end of part B. And part B is worth only 2 points. There was a lot going on there for only 2 points. But that's because part C, they're going to ask you even more. Whoa, I am not going to erase that quite yet. Whoa. I want to leave f prime x up here. Okay, so the question states, find the absolute minimum value of f. Now, remember what f of x is. F of x is e to the x cosine of x. I want to find when is that a minimum value. And to find out when is at a minimum value, I'm going to need to make a table. Okay? So, in this table, we've got x, and we have f of x. And we want to know when is it at a minimum. So we want to know when will we get the lowest y values on the interval 0 to 2 pi. And remember, who can win the absolute minimum awards? Endpoints? Or critical points. So my endpoints are 0, 2 pi, and then my critical points. And I want you to notice I'm leaving 2 critical points because I've already cheated. I've already looked at the answer, so I'm saving space there because there are going to be 2 critical points. So the absolute min or maxes can occur at endpoints or critical points. Those are the endpoints. We need to find the critical points, and that's the reason I saved this derivative up here. The derivative is how I find my critical points. I need to know when is the derivative equal to 0. And if I want to know when is it equal to 0, I'm going to GCF out an e to the x. Alright, well let's just start here. When is e to the x going to equal 0? It's never going to equal 0. E to the x is never 0, it's always positive. If you look at the graph of e to the x, it's always positive. So e to the x is always positive, so it's never going to be 0. So if we don't have to worry about e to the x being 0, we just have to be asking when is this equal to 0. And if I add the sign to the other side, I get when is cosine x equal to sine x. So this will equal 0 when cosine and sine are equal. Well, let's cross out some ideas. Where does this not happen? Cosine and sine are not equal at the quadrant angles. At the quadrant angles, one of them is always a 1 or a -1, and the other one is a 0. Remember, if that's cosine and sine, they're never equal. So remember, on the AP exam, when it comes to sines and cosines and tangents, you're responsible for quadrant angles and your triangles, your pi over 3, pi over 6, pi over 4 triangles. So let's go ahead and look at those 2 triangles. So why do I know it's not a pi over 6 triangle? So here's your pi over 6, pi over 3 triangle. Whoops, sorry about that. Well, it's because sine is opposite over hypotenuse, like 1 over 2, and cosine is adjacent over hypotenuse. So 1 over 2 is not the same as square root of 3 over 2. Or over here, square root of 3 over 2 is not the same as 1 over 2. So it's not a pi over 3, pi over 6 triangle. So what about a pi over 4 triangle? And we have seen this problem before, something similar. And this is the triangle we're looking for. Notice that opposite over adjacent is the same as, opposite over hypotenuse is the same as adjacent over hypotenuse. Now, if it is a pi over 4, then the question is begged, which pi over 4 is it? So we got our pi over 4s, we got pi over 4, 5 pi over 4, 7 pi over 4, and lastly we have 11. Wow. Right? Right? 9, what? What? I'm so sorry. I need to go to bed now. I'm sleepy. I don't know what happened there. There we go. My brain was just doing its own thing. But anyways, if you go to all students take calculus, all students take calculus, these are the two that are going to have them being equal. Here they're both positive. Here they're both negative. Either way, they're both equal. In this quadrant, one's positive, one's negative, not equal. Here, one's positive, one's negative. So this equals 0 when this equals this at x equals 5 pi over 4 and pi over 4. Alright, and that's a lot of work, and now we even have to do more work. We've got to plug all this crap back in. Okay. So I'm going to take all this stuff and plug it back in. I probably should just leave this. Okay. So let's go ahead and plug in a 0. If I plug in a 0, e to the 0 cosine of 0, e to the 0 is 1, cosine 0 is 1, which is 1. Now let's plug in pi over 4. E to the pi over 4, cosine pi over 4. I don't know what e to the pi over 4 is, but I'm going to leave it e to the pi over 4. I'm just going to leave it. And cosine of pi over 4, cosine is positive in this quadrant, and it's 1 over the square root of 2. I'm not going to simplify that. Alright, let's try the next one, 5 pi over 4. So e to the 5 pi over 4, cosine of 5 pi over 4. And again, e to the 5 pi over 4, I don't know what it is, I'm going to leave it, but I do know cosine in this quadrant. We talked about all students take calculus. In this quadrant it's negative, so it's actually a negative 1 over the square root of 2. And the last one I'm going to do is I'm going to plug in 2 pi. So here we have e to the 2 pi, cosine of 2 pi. Cosine of 2 pi is the same as cosine of 0, which is 1. So I get 1 times e to the 2 pi, or simply e to the 2 pi. Now you might be wondering, Mr. Pygott, how do I know which one's the smallest? Well, positive, positive, negative, positive. There you go. So, absolute minimum of f is, and you could just say f of 5 pi over 4 negative 1 over square root of 2 e to the 5 pi over 4. Remember, when they want to know what the absolute minimum is, they want the y value. They didn't ask for the x coordinate, they wanted the y coordinate when they say the absolute minimum. Anyways, that's it. That's part C. It was a crazy question, and it was worth 3 points. All right. And now we get to part D. This question is taking so long that my computer shut itself off. I am sorry. All right, part D. Folks, there's a limit question on the test, probably L'Hopital's, so I'm going over some important information here about what you better do on L'Hopital's. So first thing I'm going to do is I'm going to plug in pi over 2. I get f of pi over 2, g of pi over 2. I know g of pi over 2, they told me is 0. I know f of pi over 2 is 0 just because I know that's what it's going to be. But if we go ahead and plug pi over 2 here, f of pi over 2 is e to the pi over 2 times cosine of pi over 2, and cosine of pi over 2 is the x coordinate here of 0. So anything times 0 is 0, so it's 0. So you need to show that you've plugged it in. You need to show 0 over 0. You have to put 0 over 0, and you must use the words use l'hôpital, le hospital. Okay. Now that we've said that, we have to take the derivative of the top and bottom separately. And they said this year that when you take the derivative, if you don't recopy this limit part down, it seems stupid, like who cares? If you don't copy this down, you can only get 1 out of the 3 points. It's crazy. So we got to copy this down, and we got to take the derivative of the top and bottom separately. So no quotient rule. L'Hopital's is take the derivative of the top and bottom separately. Derivative of f of x is f prime x. Derivative of g of x is g prime x. And now I'm going to plug it in. Okay, so little bit of craziness. Let's go ahead and start with this. What is g prime pi over 2? G prime pi over 2, the whole reason they gave me that whole graph for one thing. Literally just to have that one ordered pair. This is the graph of g prime. So g prime pi over 2 is actually just looking for an ordered pair in the graph. The ordered pair is 2. And now we need f prime 2. Did we f prime pi over 2? Oh my word. Do we really have to go all the way back and find f prime pi over 2? Wow. Crazy. Dang. Dang. Wow. We literally have to go back to our derivative. Remember our derivative of f prime x, which was first piece times derivative of the second piece, plus the second piece times the derivative of the first piece. And we got to go way back in here and plug in a pi over 2. We get e to the pi over 2 times a negative sine of pi over 2. The good news is cosine of pi over 2 we just said is 0. So all this stuff over here is 0. Remember, sine of pi over 2 is 1. So we get a negative. We have this negative. The sine of pi over 2 is 1. And then e to the pi over 2. Wow! So negative 1 e to the pi over 2. And that's it. That's all you have to do for part D. Great. Get the points you can get. Remember, 5 out of 9, you're talking about a 5 on the AP exam possibly this year. 3 or 4 out of 9, you're passing. So some questions are hard. That's okay. Work hard. Get the points you can get. Run away and bye.